My name is Marian Edu, and I'm going to talk today about a topic that is somehow contradictory in terms. It's model-driven design and Agile. One will say that those terms are really a contradiction, so you cannot have them put together in the same sentence, but I'll try nevertheless. Well, there are so many paradigms about the model-driven software development. The terminology here is quite complicated. We have MDA, which stands for the model-driven engineering. Then OMG come up with their own implementation of MDA that's called model-driven architecture. And then we had model-driven development. And then on top of that, we started to talk about UML, which is something that also OMG made a specification for it, and it was something that, was meant to be something that where you can specify every pieces of your software development process and the product itself. So it started from the use cases, then stories, and everybody was talking about that. It was a period in 19th, then everyone was doing that. So believe it or not, OML was on a hype at some point. Not anymore. And I think the history of those unfulfilled promises of OML, it's hurting now the whole model-driven development initiative all over the place. As I said, the modeling, the idea was to start from the use case, where you can involve the business user. So you can start to write those user cases and scenario, and then from that, the analyst starts to work with the component diagrams and go down to the class diagrams and extend that with integration, where you can specify actually the behavior of those components. There was some interpretation here. Some of the, let's say, the guy that were pushing that idea a little bit too far say that we should have everything into the UML model, so you can actually generate everything from the UML, from the model of your product, or actually have some the model interpreted, so you can actually run the model and execute them in some kind of AVM or virtual machine. Those were two ideas that were actually stretching a little bit too far. So it was a kind of a top-down approach. The source of everything was the UML model. That was the deliverable of the design or development, which was not the case, because although it was supposed to be easy, the UML, it's not very easy for developer to write code in UML. So actually, that had to stop at some point. But there are some values there that I believe that we can still use even in that agile world that it is today. And I think that we can still think about component and class diagram. That is something that the developer can relate to. And maybe we can just keep that use cases and the interaction diagrams, because really no one wants to write the behavior inside of UML model. Well, the problem with UML is that currently it's not cool. It's not seen as a cool technology anymore. The model-driven development in itself, it's seen as a failure. It's not something that people are willing to do. That probably comes from those bad memories from UML fever, when everybody started to work with UML. If you remember, Enterprise Architect was a good thing in Progress, and Progress software did build a framework on top of that, IMO, I think, that was making a lot of use of UML, especially Enterprise Architect. So yeah, we tried that, we've been there. I think also the 4GL for most of the developers is seen as not cool. Might be the case because for the renaming of the 4GL to ABL, but it's the same idea with the UML. And one of the reasons for not being that cool among developers is that the UML and the model-driven approach is coming mostly from the academic part, which they tend to make it too strict and too complicated for the regular developer. Another issues there is that the manager doesn't like that UML and model-driven design either, because they say there are no benefits for that. One of the idea behind the modeling in general was that the code that is going to be resulting from your design phase is going to be more maintainable and is going to be in general better than just if you start writing code. But still, there it's difficult to make a case with a manager even today. And besides that, the average developer hates it. They just want to write code. This is something that they better try to stick with the skill set that is not that relevant for them, but it's instead of trying to acquire a new set, they don't see really a value in that part. Although the skill set that they are trying to keep, it's not that relevant nowadays. I mean, people writing COBOL or even old 4GL, it's probably not going to be that relevant. But there is still a lot of reluctance from the developer to adopt that kind of thing. Another problem here is that, as I said, the UML is not on hype. The hype now is Agile. So that's one of the strips from the Dilbert that it's actually captured that idea very, very, very well. If something is on hype, everyone feels the urge to use it. They are not really sure and convinced why they did it. The customers demand for them to do it, so they end up doing it even if they don't know exactly what was the purpose for all that. So sometimes being cool, it's enough. We see that all the time nowadays with new technologies. Cloud is probably going down the hype a little bit, but it's still there. But there are also new languages that new developers are always excited about. And one of the things is that it's something new. They get that idea that it's something new, that they have to do it. I think there that the clash between the model-driven software development and Agile might be seen because most of the time the model-driven technology, if you see it from the top down, it's the model-driven software development can be seen as a methodology, not just a technology. So you have to, there's a process, that comes, probably it's very close to the waterfall approach, the waterfall methodology approach. You have to design a little bit for that. then you have to code it, then you test it, you put it in production, and then you rewind the cycle and get it back. And Agile, it's a little bit different. They say you don't have to specify that much upfront. You just have to start doing something. Then you do that in very small increments, so you can test that to the customers and check out the results, see if you are going on the right path or not. So if you think about model-driven software development as a methodology, then yes, it's virtually impossible to use two methodologies in the same time. If you are going Agile, you cannot do model-driven software development. There are a couple of, let's say, users of model-driven development approach that are trying to rebrand the whole idea. And we see now platforms that are rebranded as low-code, no-code, which is pretty much the same idea, just it's you put a new name on it. But what I think it's better for people that thinks that there is still a value in doing some modeling upfront. I think we should focus on that guerrilla warfare. This is a term that I liked it from. It's taken from one of the posts on Melee. It's a guy it's a Dutch guy that works for Xtext and other domain-specific languages, technologies. He proposed that idea that we should focus more on low-hanging things that we can improve in the software development process, instead of thinking about model-driven development as a top-down process. So instead of doing that as a methodology, we can see it as tooling, as technology. You can help developer by lifting out some of the, I don't know, boring and tedious stuff that they do in everyday development. Like, for instance, I don't know, generating data model object, which is something that no one wants to do it by hand. So the idea there is to see that as a tooling, instead of trying to sell it as a full top-down methodology. And what we mean about guerrilla warfare is that I also relate very much to that statement from Ken Thompson. One of my most productive days was throwing away 1,000 lines of code. This is something that a guy that is not really happy with doing development and doing the same thing over and over again, this is something that we should aim for, because we have this compulsive or obsessive, might be a disorder or something like that. You always try to improve your code. So this is one of the, let's say, best days of those kind of guys. If you can reduce the number of code that you've written before, it's going to be cleaner, more maintainable. So it's always it leads to a better code. We are not going to make a better world, but just a little bit maybe. We should try.
Less is more.
Less is more sometimes, yeah. Okay, this brings back to the OpenEdge world. So Progress come up with that OpenEdge reference architecture a couple of years ago, many years ago, I will say already. So it's all focused on model, so data models, because being a database provider, they work with data. We have in Progress a lot of data structure, temp table, data sets that all Progress developer works with on a daily basis. In OERA, we have proposed those data access object and business entities. On top of the business entities, we had model. If you use a model view controller pattern on the UI, and of course the view, which is actually the user interface that is going to work with the model, getting data back from the business entities. Normally, this is the whole structure of the Open Edge reference architecture. What we can do there as trying to follow this model-driven development, it's to actually start from the database. This is for a progress developer, this is the root of your application. This is the model definition that you start with. From that database definition, it's very easy to see what is there because we have every database provider has that metadata information that you see the structure of the tables, the fields, what are the properties for those. Well, yeah, progress somehow lack in that relational, from relational database management system, the relational part, it's a little bit left out of the picture for progress. We don't have really relations, as in foreign key constraint, but we, yeah, everyone is probably using triggers, still using triggers as the only option to enforce database integrity, but we don't see the relation between tables. So somebody has to really know what are the relations between the tables, because just looking at the database metadata, the information is stored in the progress Open Edge, you don't see that kind of information. Yes? Implicit, yeah, it's self-explanatory by using the, yeah, thank you, Wim. So with that idea in mind, we start to think about entity relationship diagram for progress, where there are a lot of entity relationship diagram designers out there. Erwin, to start with the probably most known one, for instance, there was a plugin at some point even in an enterprise architect that allowed you to design your database in that one, but we say maybe, well, progress is really a specific and unique case in that database design because we have all those properties that are really should not be part of the database design, like format, message validation, it's really not part of the database, but progress being an embedded language, they use that to be able to generate or use that information when we created the UI. So we say maybe it's a good idea to create an entity relationship diagram that it's specifically designed for progress to support all those, let's say, properties that it's very specific to progress database. So the idea with data-driven development is that we should always start from the database model. This is our initial model that we can start from. Everything that we do is derived from that. We can create business entities or business objects from that definition. On top of that, beside the UI, we can also add service interfaces that it's also using the business entities or business task or business object or whatever you want to call them. It's more or less the same idea. But what the intention here was that if you have a database model, then using that information as a reference, you can create the business entities. And you see that the business entity is using a specific table and specific field from that table. And afterwards, using the business entities that you've modeled, you can use those to expose the method of those business entities as service, or you can use them in a UI design where you can So you always have the relation, so you can track back from your UI definition to the business entity and back to the database, so you can actually see what is the data that you are going to present in the UI or in a specific service interface. That was actually the main idea behind the whole thing. It's not very good. This is how the entity relationship diagram looks like in our previous implementation. It's a little bit improved nowadays, but it's, the idea is the same. You have the tables, and we extended that with the ability to create relationship between the tables. This is something that a database designer usually does. It's also a very good tool for documentation for new developers that are coming into your project. So if they get a diagram like that, they can actually relate to the tables. You can put more information there, like description for those tables and fields. So then it's easier to find their way through the application data structure. Because otherwise, if you start, for instance, working with a QAD, MFG Pro, then there are thousands of tables there, all using different anachronisms, especially in the older version. They've changed that at some point, so now it's a little bit more self-explanatory, but it was a nightmare at least when I started with that. It was very difficult to find out what is the relation between tables and how you can put them together in a query to get the data for a report, for instance, or get the data to display in a grid. So that's something that can be useful for, of course, because that information is not present in the progress metadata. Someone has to go and create that and add that information on top of the existing one that we can import directly from the database. What I found very interesting and useful for as a tooling part in this model-driven development approach is the use of domain-specific languages. Domain-specific language is something that is not a common language like Java or even Progress or Go or whatever language that you use. It's a very specific language. It's something that someone designed for his own purposes. It's should be very the intention of that should be very, I don't know, self-explanatory. Let's say it shouldn't be, I don't know, I'm losing. Yeah, it is not something that is generic. It's something that it's really meant to be used by your use case. So it's for a particular domain problem. That is a particular domain problem, yes. So it's not a generic purpose language. What it helps you is to create an additional level of abstraction. So you know that if you want to design a user interface, you need to create the database model object. Then you have to create the user interface and specify what you see. If it's a maintenance screen, then you have a lot of fields that are going to be editable on that one. You have a filter or not. If it's a grid, then you have to specify what column is going to be presented there. So if you want to create that, specify that in an easier manner, you can create your specific domain language that says a grid or form, and then inside the form I want a grid with only the columns that I want, and for each column I can specify a label, and then it's just a language that you create for your own specific problem. It's the syntax of the language. It's something that you define, so it can be as simple as possible, or as I don't know, poetic as possible if you are inclined to writing poems, or it can be as cryptic as possible. If you are preferring more the, I don't know, regular expression or Perl, you can do it that way. But then probably it's going to be only you that are going to use it, but yeah, that's another story. So the idea is that it promotes the intentional programming. You specify what your intention is there. And you are doing that in your own syntax. And from the idea behind that is that using that model, the domain-specific language is going to allow you to create a model that specific the intention of your what do you want to achieve from that piece of code. And having that model, you can afterwards generate, I don't know, maybe Angular code if you are using an Angular framework, or .NET, or WebAssembly, or specify your JSON definition, the service definition file from that model. So there's a lot of things that you can get generated from there. Yeah, there are two options for the domain-specific language. One, it's external DSL, which is different from the language that you are using for the host. And this is the case that we have here. It's mostly, it's not very wise to start using a DSL that is using ABL. What you want to achieve here is to have a domain-specific language that is different from what you are going to use when you generate the model. What is the implementation of that, the resulting code from that domain-specific language. And another option was to actually have an internal domain-specific language which morphs the host language in itself. So you actually integrate the language that you are using inside the domain-specific language and maybe extend it a little bit. This is the conventional programming paradigm that we actually live through. It's we write some code in, I don't know, .p, CLS, CS, whatever extension we have. It's a JavaScript or a TypeScript. And then the compiler is going to parse that, generate probably some intermediate code that is going to be, in our case, in case of ABM, is going to be interpreted by the virtual machine at runtime, or it can also generate binary code that is going to be executed directly. And then we do that again. If you want to change something, you change the code, it's going to be compiled, you generate something, and the runtime is going to be executed. While in domain-specific languages, we have that concept of software factories. You have an abstract representation that it's written in your specific syntax, and from that you can generate source code. So that's the source code that is going generated is the deliverable of the model. It's actually seen as a storage. Today it can be a Java code that you are going to generate from them. It might be a C# code. The only part that you have to change if you want to switch from Java to C# or I don't know, TypeScript is the generation part. The model, the intention, the behavior, whatever you put in that intentional declaration of your program, of your piece of code, remains there. It's in your domain-specific language. If you ever decide to switch to something else, you can generate and just change the generator. So it's going to create something else. It's not going to do the compile part. Once you generate it, you have to go through the compiler, and then, yeah, if you want to generate progress code, you can do that. It's going to generate code, but you have to compile the code as you do with any other progress source code. That's the same for Java or C#. You have to go to the compiler. We did a lot of work in that domain-specific language area. The product that we use most is the Xtext textual modeling framework. It's very powerful for developing your own domain-specific language. It comes with a lot of features out of the box. It's going to be able to, it's based on NTLR. There's the same thing that ProParse is using, only that it added, let's say it's a domain-specific language on top of NTLR. You don't write the grammar using the NTLR format. There is a little bit of the difference between that and Xtext format, but it comes with a lot of added value. You can get an Eclipse editor that is going to give you code completion, cross-references. You get the outline view out of the box. You don't do anything for that. It can also generate, I think Jill is going to have a next session talking about language services. Yeah, so it also provided out of the box. You don't have to do anything. You just start that and you can write code in your domain-specific language. You had code completion and everything in Visual Studio Code or, I don't know, Eclipse Key or any other things that support that language server that it's going to be probably the next, everybody is probably going to embrace that at some point to allow web development, so a web development environment. Other thing that we use for that area was the Eclipse modeling framework, which is the core part of that modeling design. It provides the eCore, which is not really like an UML, but it's the default representation of models in Eclipse. That translates to, it's also automatically serializable to EXMI format, which is an extension of XML, sorry. And then we also use the graphical modeling project for the diagram, for the graphical part of that. If you want to extend your DSL and make that in a graphical representation, because it usually, if you write a domain-specific language, it's something that you have to type in. You open an editor and write the code using your syntax, your own syntax that you define, but it's something that is not doesn't have a visual representation. It can be possible to extend that to have a visual designer on top of it. Those are the main components of Eclipse modeling framework, UML and Acorn. This is something that they use for storing the model. EXMI, I said it's XML metadata exchange. You can import XMI model and then translate them to something else. It can generate model classes. This is something that it's doing. You describe your object the same way you do in UML case diagram and class diagram, sorry. You define the object, the method, the properties, the type of each properties, and then from there, Acorn is going to generate the model classes for you, and you get also an editor that has a property view. It shows you all the properties. It's very nice. It's also kind of a model-driven design approach in itself, because you specify everything in your Acorn model definition, and from there is going to generate a lot of Java code for you, the whole boilerplate that you can only extend if needed. So it's also generating a basic editor, which is kind of a reflective editor. It's using reflection to see what kind of properties are there, so you can change those properties. One of the domain-specific language that we have to build for our purposes was the data definition syntax in progress. Yeah, I don't know if anyone is writing a data definition file by hand, but it could be, yeah, maybe Daniel. Yeah, but it's probably sometimes faster than going through data dictionary and doing that, adding a lot of fields. In data dictionary, maybe it's sometimes faster to do it directly in a DF file. So the data definition language that we built, the domain-specific language, was actually specific to that data definition language of Progress, where you can add tables, update tables, add fields, add indexes, update, everything, all the statements that are possible in a data definition file. We had to write a syntax for that, and we support all the properties and whatever you have to write in there. It's adding new triggers, yeah, we.
Do you also have add relations?
Doesn't do anything. I'm not sure what Progress is going to do if we try to load a DF file that has that relation. Probably it's going to throw an error because it doesn't know what relation means. Now, as I can say, everything comes here. If you open that in an editor, you get the syntax highlight and you get code completion for all the properties, and then you get the outline view and then a property view that it's missing from that picture. So if you select an object here, you have the properties. It's going to select that specific object in the editor. It's a lot of interesting features that you get just like that. You just have to define the specific language, and then it's going to generate that for you. The idea that we try to extend our entity relationship diagram designer is to be able to add in-memory data structure. So to create data set or temp table based on the data structure of the database, then use those for business object or business entities. Try to come up with kind of business catalog where you can expose those business entities or not. It's also something that you can expose as services, and maybe, although designing the user interface, it's usually something that the developer wants to see it in a what you see is what you get manner. So if they want to drag a component, they want to see eventually the component as it will look at runtime. But another option will be to just create an abstract user interface. That, yeah, it's an option. You know that there is going to be a grid there. You get to define the fields that are going to be present in that grid, but it doesn't show you exactly as it's going to look like, because one of the reasons here is that if you're doing that in an abstract manner, you can change or swap the actual implementation, so it's going to look different if you generate web UI as compared to what if you generate a Java or .NET UI. But I think there is still a value there. Maybe it's not as productive, because if you have a developer that is used to write and develop user interface using Visual Studio Code, for instance, it's going to be easier for him to do that from Visual Studio instead of describing that in an abstract user interface, generate Visual Studio Code, and then run that. So it's more productive if you have a graphical development environment to use that. But what it gives you the kind of independence from the actual implementation. So you can say at some point, well, I still have part of that behavior and intention that I use. That was described here in kind of an abstract manner. What could be the benefit of using that, that model-based approach? One of the main important things that it can provide you is the documentation. Nobody seems to care that much about documentation nowadays, especially if we talk about Agile methodology. You start coding right away, then there is a lot of code that is going to be delivered. It's true, most of that is going to be trashed away and started again in the next sprint and then trashed away again, but eventually you're going to have some deliverables. So that piece of code that you are going to deliver, it's probably not documented at all or very bad documented. So the documentation is something that lacks, it's something that is lacking more and more in the deliverable that the software development process create. While the model, it gives you at least the intention of that, where do you want to go. It can help also the technical and business view. If you create that business catalog, if, for instance, if you have your database model, then you put on top of it a business catalog that can be used for report. This is a solution that most of the reporting, let's say, BI providers use. They get your data source and then they create an universe or a business model out of it, so it makes sense for the guys that are going to write the reports. It provides you some kind of traceability. Impact analysis is something that it's very important for development. What if, let's say, what if I want to change that field from character to integer? What is going to happen? How many, how this is going to affect my source code? This is something that can be automated or not. I mean, it should be possible to do it. And of course, this is something that you should do that if you have a lot of things that you need to generate. Whenever you want to generate data object models, it's better to have a model. So it helps you to generate the boilerplate code that it's most of the time very boring and a tedious job that the software developer has to do. Somebody has to do it, yeah.
But for the impact analysis, don't you need the source code as well to be able to say where they interact across reference?
Well, if you are talking about soft code, yeah, the question was that if you want to use or the impact analysis functionality should imply that you have to have access to the code itself. But the model is not aware of the code. It was an idea at some point of providing also the reverse engineering, which is not really the model-driven development, it's the other way around. So you, from code, you parse that code and come up with a model. But in theory, the model doesn't know about the implementation. So it doesn't know about the actual source code. But if you have that in a model, then you know that if you change something, that is going to affect your business entities. What are all the business entities that are using that field, and then all the services down the line and the user interface that is going to be affected by that. So you just have to see if that is probably possible, otherwise it's going to probably create too many changes in your source code that it's probably not worth it. You create a new field or whatever, so you find another solution. But it's not tied to the generated code. Yeah. The idea at some point was that we should have the other way around included into the solution. So you generate the model. From the model, you can generate the code. Then you have an option to change the code a little bit and reload it into the model, and then you can. But it's also very difficult to keep them in sync. Most of the time, you are going to have a different specification in the two places. Yeah. So I think that concludes my presentation. I have no idea if I'm on time or... Okay, good. If there are any other questions... Good. And thank you.